All right, this question is possible bipartition. So there's two main ways that we can go about solving this question. One of them will rely on union find, and the other one will just rely on graph traversal, and we also label the nodes at the same time. So in an interview setting, I would probably do something like this because I can't pull union find off the top of my head. But union find for this question would actually be preferred given the way that our input is given to us. So I'll leave a link so that you can read more about union find if you want. But in an interview setting, we know how to traverse graphs, and we just have to apply this labeling logic on top, and that's something that we can come up with during the interview. So I'll show you how we can do that starting from the question. So in the question, they give us this idea that we want to end up with two groups. So I guess one group here and one group here, such that the people that dislike each other are in separate groups. So here, one dislikes two, so they're in separate groups. And here, three dislikes four. So we'll just put them here for now. Three dislikes four, so they should be in separate groups. And then we know that two dislikes three. So actually, from here, we know that three should be here. And because three dislikes four, that means four should be here. So this gives us a good bipartition. The people in here don't dislike each other, and the people in here don't dislike each other, but the people across do dislike each other. So if we visualize this as a graph, what we'll have is we'll have each of these dislikes as an edge. So we have one dislike two, three dislike four, and also two dislike three. And what you notice about this graph is that when we're able to split it into two groups like this, we're not going to see any edges between members of the same group, right? So the edges are always going across from one bubble to the other bubble. So that means our solution will be traverse the graph and label it at the same time. And by label, that's just like, for example, let's say everybody in this group gets the green color and everybody in this group gets the blue color. So we start off, just pick up a random node and we will label it green. So now we know that because every edge goes to somebody that it dislikes, it should have the opposite color. So if it was green, then it should have the color blue. So when we come across here, this should have the color blue. Now from here, as we take this edge, this should go to people that it dislikes. So now it should have the color green. And then finally, from here to this blue, it should have the color blue. And at this point, this is a happy case. We're able to successfully label all nodes. Okay, so let's see an example where it's not successful. So let me just copy this down. And then all we'll do here is we'll just add in another case. So let's add in, for example, actually 1 dislikes 3. So that means we've actually added in an edge right here. So let's see what happens when we try to color. So again, we have this green label, and then here we follow it to blue, and then blue again, we go here to green. And then this green, well, it's going to follow this, and it's going to try and label this blue, right? But this is already labeled, and it's already labeled green. So it's already marked as a friend, but I'm also trying to mark you as an enemy at the same time. So now there's a conflict. So this becomes red, no bipartition possible. So no bipartition is possible when we detect this type of conflict of where it's already labeled one color, but we want to label it a different color. Okay, so let's go about trying to solve this question. So the first thing that we want to do is we want to come up with this graph representation of our question, because our input is only that there's in this case there's 4 nodes total, and that these are the edges. So what I want to do is I want to represent this as a graph, and I'll use some sort of an adjacency list. So what we'll have is we'll have 1 here has an edge to 2, and also an edge to 3, and then 2 I guess because of this, also has an edge to 1, but it also has an edge to 3 here, and then 3 here has an edge to 4, and then 4 has an edge to 3. Actually, I missed some. So 3 actually also has an edge to 2, and it has an edge to 1. So you can see if I copy this diagram here, we have that 1 has an edge to 2, an edge to 3, 2 has an edge to 1 and an edge to 3, 3 has an edge to 4, 2, and 1, and then 4 has an edge to 3. So we've represented this graph using this kind of format. And then what this looks like is this just looks like an array. So here we have an array, and these will be our indexes. So this will be our index, and then this just looks like an array list. So what we want is an array list, an array of array list, where array list at I would give us, for example, array list at 4 would give us this array list 3. So these are array lists, here's our index, and this is all wrapped in one graph array. So graph array, which will just look, really, it's just an array list array. Okay, so enough talking, let's get down to coding. All right. So because they don't give us a graph representation, we're going to create it right here. So our array list of integer, but it's an array, graph equals new array list, and it's going to have n plus 1 members. So this will allow us to index from 1 all the way up to n. Technically from 0, but we only care about it from 1. Okay, so there's our graph, and now we're going to read in each edge from our dislikes. And then what we'll do is int a equals edge at 0, int b equals edge at 1. And if graph at a, so this node, if it's null, then we will construct it for it. So graph at a is going to be equal to new array list. So now we can start keeping track of an array list of edges for this node A. Similarly for graph B, we'll do the same thing. And then now we have to create the edge. So remember, we want to create both sides. So graph at A, we're going to add in this edge B, and then graph at B, we're going to add in this edge A. So what's happening here is that we're doing 1, 2. We're going, this has an edge to you, but also you have an edge back to me. So there's 2 arrows pointing to each other. Okay. So now we have our graph at this point, and now we need some sort of way to track our colors. So we'll do some sort of int colors equals new int, and also n plus 1. And this will keep track of the color of our node. Really, it's the label, so I'll just say it's a label of our node. Okay, so now what we want to do is want to make sure that every node was able to be successfully labeled. So if label at I equals 0, that means I has not been labeled yet. So now we will read every single node. So remember, our nodes are indexed from 1 to n. And what we want to do here is if graph at A does not equal null, so there's edges there's edges that need to be processed, and label at, sorry, this should be an I, label at I equals 0, so we haven't labeled it yet, and we find out that it's not bipartite for this graph with this label at this node with this label. I'll call this labels. Then we can return false. Otherwise, if we've processed every single node and we found out that they were able to be successfully labeled, we can return true. Okay, so now we have that. Now we have to write out this helper function is bipartite here. So in this case, I'm doing DFS for our graph traversal. So let's have our private static boolean is bipartite. We're going to take in our graph, which is an array list of integer, which is also an array graph, our node that we're trying to process it at, sorry, and then we have our labels here. Okay, but we also need to know what to actually label it, so we'll also have our final label. And this label could be anything you want. So for now, I just put in 1. So green means 1, so I'll label it 1. Okay, so what we want to do here is if graph, so if labels at node, I guess if it equals to, if it does not equal 0, and labels at node does not equal label, then we can return false. So this means that it's already labeled, but it's not the label we want, so not bipartite. So this is a conflict. So conflict, we return false. Otherwise, if labels at node is already equal to label, so we've already processed this node, we can just return true, we're done. So if those cases don't pass, then we can now do labels at node is going to be equal to label. And we want to process the edges. So for int, I guess, other node, so int edge in our graph dot get node. So now we're looking at each edge. We want to check to see if is not bipartite with this graph, with this edge, labels. And now we want to give it the opposite color. So here what you can do is you can give it the opposite color, like we can use a negative sign in front so that it flips back and forth. So if you had 1 before, it would next, so all your neighbors would get -1, and then all its neighbors would get 1 again, so it can flip back and forth. Or you can use the binary operator, the unary not, that would have the same effect as well. So if it's not bipartite, we can return false. Otherwise, we check through all its edges and it all looked good, so we'll return true. Okay, let's give this a go. Let's see. Right, so this should be labels. And what else? Graph.getNode. So it should be graph at here, at this node, we want to read each edge. Okay. Cool. Let's try submitting. All right, so let's talk about the runtime a bit. So for the runtime here, we've already went through all our edges. So at least it's O of E right here. So this is already O of E. And then here we had to go through every node. So this will be every single n for all our nodes here. And then inside here we call is bipartite. Now is bipartite actually goes through the edges. So you might think that here this makes it become O of n times E. But we only visit each edge in our whole graph only once, right? So we'll never like repeat going to edges because these edges are all unique. Therefore, it's actually just O of n plus E, so all our nodes and all our edges. In terms of space, we had to allocate every node, we had to give them edges, so this is also O of n plus E. Okay, yeah, that's it for today, and I'll try and catch up to the other videos that I've missed, so I'll see you next time.